paragraph, so if you could put away your electronic devices, I would greatly appreciate you putting away your phones and also your AirPods. Someone please ask Jaron to be quiet. Get out your notebooks, put away your electronic devices. That includes AirPods. Do you have pass? No. That includes your AirPods, your earbuds, all of that. Please do not jeopardize your success in my class. I have 50 minutes with you. Give me that time, please. We have a capture question up on the board that says, what do you know about global warming? So I want you to write down what you currently know about global warming. I want to let you know that we're going to do our capture question, and then we've got a lab on greenhouse gases. It's going to look really familiar to a lab that we did on heating and cooling of water versus soil. And there is a link on the page 3, I guess, and it is your homework for tonight. Okay, so that is going to be what you're working on tonight. Upcoming reminders. The day after tomorrow quiz is on Canvas right now, so you can take that on your own time. It's just a link, it's on there, and you just fill it out. You can use your notes. It's an open note quiz, so use your notes for that. And then I want to let you know that your final exam for climate and climate change is this Friday. So at this point, everybody should have your notebooks open.
Nope, that's not the date.
Should get your stuff out. I'm going to now be quiet for a minute, which we all know for me is tough. What do you know about global warming? I'll look around to see who is gone, who is here, and who is late. Excited about this lab.
Okay, I'll look this way. I'm not looking cold.
All right, there's our timer. Could you please turn with the person next to you, my favorite class of the day? And, oh, now I got that on video. Could you please turn to the person next to you and for 16 seconds, and Kendall, if you wouldn't mind talking to the people behind you, I'd appreciate that. What do you know about global warming? Ready, set, go. 16 seconds. 16 seconds. 16.
How'd you think it
Get your nails done.
Hey, what do you think?
Yes, you did get your
I
nails
can't tell if I
done.
should make a joke or not.
That is
Like crash, I was like 9.
He lost his steak too.
what do you know about global warming?
That's cool.
All right, here's our timer.
No, whatever.
Hey, what do we know about global warming? Someone get us started. Rebel. Sam, this way. Oh, you already did it.
Wow.
Okay, in global warming, this is, you're saying making the ice, hush please, the ice melt quickly? What ice? Okay, so we're talking about poles. Okay, so because of global warming, the ice by the poles is melting quickly. Okay, what else do we know about global warming? In the back, Yuma.
It's caused by greenhouse gases like CO2.
Okay, you're saying that it is caused by greenhouse gases like CO2. All right, what's a greenhouse gas? First of all, what's a greenhouse?
It's like a.
Why not call it a red house? Why not call it a purple house?
Because you keep plants in it.
And plants are green. So a greenhouse is something that we put plants in. What's it made of?
Like plastic. Or
Plastic,
glass.
sometimes glass. Why plastic and glass? Somebody other than coal. Yeah, Cullen.
Because it's sunlighted?
Yeah, let's sunlight it. Why do the plants need sunlight? Just to keep them warm?
Partially
Yes.
because of sunlight.
Does keep them warm. Ooh, photosynthesis. Yeah, what is photosynthesis?
Oxygen.
Eating sunlight.
Photosynthesis, you're right. Oxygen comes out of photosynthesis. It's like a waste product of it. It's one of the things that comes out, that's right. But why do plants do it? Someone raise your hand, stop blurting at me. Sam?
To create its own energy.
Yeah, they create food, right, from them, and they use that food as energy. Where does the energy come from in order for them to make the food?
The sun.
The sun. And then what do we do with that energy? We eat it.
Oh.
So really, our energy initially comes from
The sun.
the sun, right? We're powered by the sun. Now, we can't stand out there and be like, oh, like Wall-E style, you know, that little robot, Wall-E. We can't do that. We can't just open up our little solar panels and like absorb the energy from the sun. So we have to eat the plants that take the energy from the sun and make it into what's called glucose, which is sugars, okay? And so they go ahead and make the sugars and then we eat them. And that's how we get our energy. All right, so global warming, things we know so far, making the ice melt quickly at the poles caused by greenhouse gases like CO2. What else do we know about global warming? What is global warming?
It's an outdated term.
What? Okay, so when heat is trapped in the atmosphere, it makes what about the earth warm up? Is the earth heating? What about the earth is heating?
The atmosphere.
The atmosphere. So heat trapped by the greenhouse gases. I guess I could just do this. By the greenhouse gases heats up the atmosphere. One of my students said earlier, Mrs. McGrain, global warming is destroying the planet. And I said, really? It's destroying it? Because when I think of something being destroyed, it's like going away. Is the earth going away? No, global warming is not destroying the planet. That's taken from a perspective of a human being. So why do human beings say that global warming is destroying the planet?
Because it's changing.
It's changing the planet how? That's affecting us.
Climate.
It is warming up. So?
We can't adapt.
Yeah.
It causes worse storms.
Yeah, it does. We can go ahead and say that. Causes storms to be stronger. Causes stronger storms. We're seeing that definitely in our daily lives. 500-year floods are not 500 years anymore, right? Derechos, I think we've had 3 or 2 derechos within the last like 3 or 4 years. That's like unheard of in the past. You know, things, when we get a storm, it's a stronger storm. There's more energy that is being trapped in the atmosphere, and that is making stronger weather situations. I like it. Does anybody have anything else they want to add that you know of about global warming before we move on? Fabulous. We're going to go ahead and do a lab today. So I'm going to pass this lab out to you. I hope that you put this in your table of contents, but I cannot make you do anything anymore because you all are high school students. So this lab, I'm going to go ahead and pull it up on the screen, and then I'll continue to pass these out. Did I tell you that your quiz is on Canvas? You can take it whenever you want. When you're at home, use your open notes. I don't care. Please make sure you take it before Friday, because Friday is going to be your final exam. And so I want to make sure that you get it done before Friday. All right. Thanks for the note. So the purpose of this lab, students will observe the greenhouse effect in a laboratory setting and assess atmospheric warming due to carbon dioxide relative, that means compared to other greenhouse gases. Now, when we look at your materials, you're going to have a vial of CO2. Vials are just test tubes. So you're going to have like a test tube filled with carbon dioxide gas, a test tube filled with H2O vapor, that's just water vapor. Water vapor is a gas. and a test tube filled with regular old air. The regular old air is going to work as our control. So here's our question. How do the rates of temperature change between carbon dioxide, regular air, and water vapor? Okay, so when we heat them up, how do they change? Here's what I want you to do. I want you to make a prediction about the rate of temperature change between the three gases. Which one do you think will heat up, which one do you think will absorb more energy, heat up quicker, and then release more energy? Which one do you think will be less? So in comparison to the others. Which one do you think will change in temperature more? Do you think carbon dioxide is going to change in temperature more? Do you think water vapor? Do you think air? What do you think? Write something down. It's okay if you are not correct, but I don't want you to just kind of go into the lab with nothing. So just put something down. I'm going to try to change up our groups just a little bit today because I always think it's important that you get to work with different people in your lives.
And then you pick which
While you are finishing putting down your ideas on which one do you think is going to have a greater effect on temperature change, I want to let you know that it is very much like your heating versus cooling lab with water and sand. You're going to heat these materials for 10 minutes. You're going to then cool them for 10 minutes. When you shut the lamp off at after the 10-minute mark, what should you do with those test tubes? Should you keep it right up there near the light bulb?
No.
No, because they're still radiating energy out. We want to move them away. And then you're going to let it cool for 10 minutes. Let's turn the page, please, and set up our graph because my last group really struggled with getting that done. They were just sitting there, and I'm like, come on, let's get the graph done. At the bottom, we have time. What are we measuring our time in? We're taking them. There you go. Let's go ahead and write minutes right in here. M-I-N. How many minutes?
20.
That means this last line is going to be 20. This first line is going to be 0. And we have every minute in between. If time is on the x-axis, what else are we testing that should go on the y-axis?
Temperature.
There you go, Jared, you're on fire today. So we've got temperature. Which temperature reading are we using, Fahrenheit or Celsius?
Celsius.
We're going to use Celsius. Now, we cannot figure this out yet, but what I want to do is I want us to, everybody break the graph. So we're going to put a little squiggly line, another squiggly line right there. All that means is we understand that there is temperature, between 0 and whatever we're starting with. It's just that none of our data points are going to be on that temperature. And we really want to then be able to use this space to stretch our data out as best as possible so that we can see how these 3 different lines are changing. Now, because we have 3 different lines, we should probably make a key. So I'm going to write the word key over here, if yours does not already have the key. And then we're going to have CO2. We're going to have a line for air and a line for H2O. I don't care what order you put this in. But you want to go ahead and use a straight line for CO2, a dotted line for air, a star line for H2O. I don't care what you do. If you want to use colors, do whatever you want. But I want to make sure that it's something so that at the end of the hour, if you run out of time, you can go ahead and work on this. Are you asking to go to the bathroom right now? Hudson, can you just wait another second? Actually, go. All right, so then let's go ahead and look at what you're doing. After we graph, you're going to answer these questions. Then if you look at the next page, everybody please look at the next page. You've got a homework assignment. It says go to the following website and answer the questions from the video and the article. So you're going to go here. I have put this link for you on Canvas. but you can also just go right here and do it. And so you're gonna be answering these questions, okay? So you got 6 little questions to answer. And then we'll come back tomorrow and we're gonna touch on this tomorrow. Does that sound good? So do you have homework tonight?
Yeah.
Yeah, you do. It's that little page. All right. So then what we're going to do is we're going to separate you in groups. I'm going to have Rubil, Michaela, Ethan, and then Addie. You 4, I'm going to put you at table 7. And then I'm going to have Will, Rebecca, Claire, and, oh my God, I want to say Lauren, and that's wrong. It's Lila. I'm going to put you 4 at table 6. And then, have I done y'all yet? 1, 2, 3. I don't know if that's a good idea.
I think it is.
Okay. 4. So I'm going to put Kendall and Alex and Billy and Alexi. I'm going to put you all at table 5. And then Karen and George and Cole and Jaron. I'm going to put you at table 4. Karen, you're a strong, independent young woman that can handle 3 mouthy little boys, but you've got it. And I love you guys. And then we've got 1, 2, 3, and then Seth. I'm going to put you all at table 3. And then we're going to go 1, 2, 3. Let's put you at table 2, and then 1, 2, 3. Let's put you guys at table 1. All right. Remember, once we turn the light on, it stays on. Have someone read the, hey, leave the lights down on the table where they were. Make sure you are reading the directions, right? And then once that timer starts and the light goes on, it stays on until 10 minutes is done. Get it going as quick as possible. And then for you people at home, I'll walk you around and show you what it's like. Let's go to this group because this is the best group. And this is our setup. Did you take the original temperature reading? Go ahead and take the temperature reading. Don't forget to start with the initial temperature reading.
Right. I'll be right back.
Oh, the CO2 is 20.
All right, it's 10 centimeters away.
All right, yeah, try to
CO2 is
center it in between
20.
so that they're all the same. Are we good? Initial reading?
We are.
Get your initial reading. No, leave it right on the table, bud.
We're all 20.
Leave it right on the table. If they're all 20 degrees that we're starting at, what does that mean about our room temperature? It's 20 degrees Celsius. 10 centimeters? No, if yours is different, then you do what you do. Okay. I just want to center it, so it's even, you know what I mean? You know what I mean? Okay. You should look at bright lights and hurt your eyes. Hey, whose is this? Oh, right.
Whoa. 29 for CO2.
As soon as Hudson comes back. All right, we got someone timing. And remember, don't shut off the stopwatch, right? Darling, can you put your phone away? And I don't have you on? Babe, could you just put it away? I know that you're laying it down, and I appreciate that about you, but could you put it away? All right, so then when we are finished, we're going to take our data and we're going to graph our data. And we are going to analyze our data.